All right, what's up? It's Dylan here, and in this video, we're going to talk about unit testing for iOS. Um, Without much background, if you're new to iOS, you're just building a lot of UI. Sometimes you're writing a lot of code, building a lot of features, but you don't notice anything wrong with them until it's out in production on the App Store and someone writes you a bad review, or your manager or your team lets you know that, hey, something's broken. Uh, how great would it be if you could just like find that issue before you even deploy it or check it into, your GitHub repo? So this is I've been doing iOS development for the past decade, and honestly, this one skill has kind of uh, taken my skills to the next level. And I think this really propelled me from, the early engineer, mid-level to senior. And it's one of my favorite topics, so I hope that you find this video valuable. What we're going to talk about in detail is just how to get started with unit testing. What does it mean to set up like the unit testing suite? Looking at it from end to end, from unit testing the domain models all the way to the UI. So talking about the domain layer, the view layer, the service layer, and of course the UI layer. What does it mean to use test-driven development? Like you hear this buzzword all over the internet, like what does that even mean? It sounds great in principle, but like, is it practical? We'll take a look at that briefly as well. Yeah, as I mentioned, service object. So you can imagine one service could be, the networking API calls to your backend, Bluetooth, um, storage layer as well. The view models, of course, like what is the logic that powers the views? We can look at testing that behavior. And on that note, we can also look at testing the behavior of UI view controllers for UIKit. Along the way, we'll cover some best practices and some common challenges, and maybe most important thing to take away too, if you're on a team that doesn't really have unit testing. I know that can be hard from experience. One thing that might be the most valuable for you is how to like bring this uh, how to bring this discussion to your team and convincing them to buy in that, hey, like we need to write tests so we can catch problems before our users do. So yeah, we're going to cover that. And yeah, like I said, my name's Dylan. I've been doing this for a very long time. I've been coaching others as well, and I would love to impart some wisdom on you. And I'm selfishly and honestly, I am making this material for me 10 years ago, and I hope you find this valuable. Okay, we're going to jump right in. All right, so why are we even talking about this? Like, what is a unit test? Why? There's a lot of arguments to be made on skipping unit tests in terms of like speed to production, in terms of like getting your features out. But honestly, I think if you look at the cost and time it takes to like fix bugs and have them be detected, it makes sense to consider adding unit tests to your project. If you're a one-off engineer, like on your own team or like your own side project, you might make the case that unit test is like, your user base isn't really that large, so you're okay with like a slower development cycle, meaning that you'll write something, push some code, and maybe at the end of the month you'll put out a release, but you're not really time sensitive. Whereas the opposite side of it is like if you work on a larger team, you'll rarely find the case where there's not unit testing in place. That would be a huge red flag if if that is the case at your team and you have a large user base. Pay close attention to this and yeah, buckle up. Another reason for unit testing is that it allows us to refactor with confidence. So as you know, the most constant thing is change, and you'll have your team constantly pushing code, trying out new things and different experiments, and you're gonna scratch some code. Like that's just the nature of the game. You're gonna like write a ton of code, delete it eventually, or reuse it in a different use case. So best case scenario for you is that like you're able to use the code that you have in place, refactor it, but also do it with confidence with the backing of unit tests. So having that behavior unit tested makes you confident in any changes that you make to that code logic. Okay, unit test is like a great way for documenting code. One of the things I love to do if I join a new team is that I like to go straight to the test. You know, the tests don't lie. And if they're well written, it really paints a great picture of this current state of the code base. So I always suggest to you know, junior engineers and mid-level iOS engineers to start at the unit test when you join a new team or company. And honestly, I do believe that writing unit tests does add structure to the code base. So, you know, architecture is such a bloated term, but ultimately, writing unit tests especially, forces the engineer and the developers to think about how the components are written, such that you want them to be loosely coupled, so they're easily maintainable and more testable. So like one thing that comes to mind right now is the idea of dependency injection. If you just like hard code things within like within a domain or within a class, and it's not unit testable, it's really hard to say that you have like, you know, good architecture, it's maintainable, scalable. So this consideration of unit tests really forces the engineers and the team to, as a result, improve the design of the code base. Okay, if you're new to unit testing, I just shared some like quick tips on how to get started with unit testing. And don't feel obligated to write all this down. I'll share this document when I'm done. It'll be either in the description of the video, or feel free to just email me. Not a big deal. Okay. And yeah, I think my Twitter might be underneath here too, but I think email might be the fastest. I check that the most. Okay, cool. So setting up your first test case, what you want to do is, if you don't have an existing iOS project, create one first. Click on the project in your navigator, select new target from the plus button, choose unit testing bundle. I have some screenshots here. Once again, if you get stuck, just reach out to me, but this just kind of walks you through what the unit testing bundle setup looks like. And if you start a new project, you can also just get it complementary with the new project setup. I think Xcode does a great job of giving the engineers like an option to just automatically include XCTest, which is like the testing framework. All right, cool. Moving along. So when you open it, it'll look something like this, you know, like this, like the standard structure of the test file, and it'll be outside the domain of your project. It'll be within the container of the project, but it can live separately outside of the module. So what that means is that you'll have like I like to think of it as like a testing environment, and your main code will be like the kind of like the production side of the project. So within this environment, you have like the main framework, the XCTest, and that's like an Apple framework that provides all of the interfaces and test helpers to write test and test your code. These are like the boilerplates that come with it. I typically don't use these, but it's a really nice way to set them up. There's like another setup method that's a little simpler, just called setup, and another one called teardown, but we'll take a look at those later on in the video. And yeah, there's some measurement tools here. Honestly, I haven't used these, but I'm sure they're valuable. Otherwise, Apple wouldn't have included those as like the default options to have here. So moving along, we're going to look at writing your first test. So let's look at an example from a real domain model that could be found in like an e-commerce app. The domain model is just, you know, the bare bones data structure that'll be used. And we're going to look at one called product. It has like an ID, name, price. Let me zoom in here real quick. All right, that's as close as I can get. And yeah, you know, think of it as like a product on an online e-commerce website. And it'll have a function called formatted price and another function called is on sale. And you know, from that, it kind of paints a picture that these properties might be used in the view layer, definitely in the service layer when we're fetching the data from the networking layer. But yeah, this is like the bare bones domain model. And yeah, I put together like a test case here, or a bunch of test cases in this test case file. And what you see here is that we initialize the domain model, maybe run a function on it, and then we assert that it meets some expectation that we are setting ahead of time. So in this GIF, I have, given that I set up like a simple product, make sure that with that setup, it has like these qualities and has these attributes. So that's what I'm testing here. And yeah, once again, like all of this will just be like kind of screenshots and high level understanding. But if you want more in-depth detail on how to set this up and see the code, just drop a comment in the just drop a comment underneath the video, and I'll do my best to get back to you with like some GitHub repo examples. But for this, we're just going to keep it high level and kind of share with you like what all goes into writing tests. So like I mentioned, the framework that Xcode provides us is called XCTest, and the assertions are like one of the most important pieces of the framework. And it's basically saying, hey, I want to test that the current state of this system, model, or whatever is what I expect it to be. So you can do that in several ways. You can say, hey, are these two values equal? Are these two values not equal? Like I want to test for equality and making sure that when I set up two instances of this class, like they're not being referenced as the same object. Is this true? So yeah, you can imagine one example could be like on the view model that like, hey, like is typing indicator set to true or false? Is it nil? So like is this value empty or like a nil value? Is this value not nil? So you want to make sure that like whatever that object is that it does it still exist at this point in time in how I'm expecting this this object to go, and does it throw an error? So with Swift, you have the beautiful mechanism to throw an error in the event of something going wrong and us capturing that error and doing something with it. You can also test that too, which is really neat. Okay, so moving on to structure. Yeah. So going a little more detail into how we set up our test, what I love to do is I like to set them up in a consistent structure that shares with the reader, either your future self or your teammates, how the tests are expected to run and what the expectation is for the results that you're testing and the behavior that you're testing. So it's commonly referred to as behavior-driven development. And it's really neat, right? You could say, hey, given this set of conditions, when I do something to this system, then I expect the system to have these attributes and these conditions or these values. So it's very readable. It aligns with the behavior that a user can expect when they're using your app. And yeah, you could really go deep into these like testing structures, but high level is that it's like a consistent way for others to read what you're testing, and also for future you to reference very quickly in the future when you come back to refactor or whatever. Okay, yeah, just share a little bit more about how it relates to other structures and patterns. Another one that's pretty common in the industry is arrange, act, and assert. Essentially the same exact thing. Arrange these conditions, act upon the system, and assert that these outcomes are what we expect them to be. If not, then fail this test. So this example, we were testing out the storage layer here, and I was using the async await mechanism, but also testing it too, and that's also testable. So I think that's a new Swift paradigm that came out in the past few years, but that too can also be testable. And what I love to do with like new mechanisms, this is like an aside, is like I like to write tests with them and see how they differ from past solutions and mechanisms. But anyways, let's keep it moving. We talked about clear comments. Okay. All right. Buckle up. We're going into buzzword territory here. Test-driven development. I think this is like a controversial topic for whatever reason. The idea of test-driven development is that you write your test before you write any code that'll be used in like your production environment. And I actually do practice this from time to time, especially if I'm like writing new features and I just want to like have a sanity check that, hey, this critical feature, for this critical feature, all of the behavior is tested and maintainable. And although the setup might be a little tedious, if I can get it to like 75 to 85% code coverage, and we'll talk about code coverage later in the video, I'm a happy camper. But it's not 100% available all the time to just start with TDD. I think for a lot of different situations, you might find yourself in a legacy code base that's really messy and doesn't have a good architecture for you to start writing tests. You might just do it small bits at a time. But I think if you want to take your testing skills to the next level, I think this is honestly like this section really brought my coding skills to the next level. Give test-driven development a shot, and for those who want to see it in the iOS context, just drop a comment and I can see what I can do. Maybe I put something together for you all so you can see how that looks like. One story on this is that I actually used TDD in a coding interview exercise for I don't know. I'll talk about it. I probably shouldn't talk about it, but whatever. I used it for Stripe, and the if I remember correctly, the problem that they wanted me to solve was just to like, put together this class that did X, Y, Z and handled payments. Show us how you would write this function. Testing is not necessary, but feel free to write tests. So I basically just, started with the behavior that they wanted to see. I like kind of did the pseudocode, and all I did was I wrote out the test. They all failed initially. Like in this example here, all the tests are written out and they're failing. And then I just wrote the code, like the production side code, that causes the test to pass. And what resulted was all of the behavior that I outlined in the pseudocode and in the test file. Once I wrote that production code to pass each test, I just ran it, and I got all green here, and I moved on to the next stage in the interview process. And I really like telling that story because I think a lot of people think that like a lot of this stuff is theoretical, but no, you can actually take action on this stuff, use it in interviews, and impress your interviewer. My interviewer was like blown away. He's like, I didn't think you'd have like time to like do TDD in an interview under pressure, but you did it. It wasn't necessary, but you did it. And a bit of warning there is like, because it's so controversial, your interviewer or whoever might say, hey, this is not the greatest use of time. But I took that risk and it paid off. Your mileage may vary. All right. Anyways, moving away from controversial topics. Testing service objects with asynchronous code. You can often see this with networking requests, data persistence, and other asynchronous operations. I have a few examples here with testing completion handlers. Here is just like making a simple API client request to get some data back for the user profile. And this is also testable. What I like to do is I'm putting the service layer under test. So I have this object called SUT, which just stands for system under test. And with that, like we don't want to be making network calls on production live. Like if you work for a large company, that's going to be really costly at scale, especially if your company uses like a CI/CD pipeline, which is like continuous integration and continuous delivery. Basically, it's like there's just like a suite of tests that are running at all times. And if you're not careful and you call any production endpoints um, within that pipeline, your company will be paying the price. So what I like to do is I set up a mock object in place of the API that would be used in the production environment, and I would mock the behavior from the production environment to this mock object. And what I like to do is I like to stub out the data that I'm expecting for each behavior that I'm testing for. So we'll take a look at a few examples. And once again, if this is a lot of information and you have any questions, just drop them in the comments below, or send me an email and I'll follow up with helpful information, maybe some GitHub repos or even more videos. So yeah, I want this to be engaging. I'm really passionate about mentoring, and this time in my life will be dedicated to some mentoring and giving back. I really learned a lot from YouTube, so I wanna give back. Anyways, back to testing network request with mock objects. We're still using the same given, when, then structure. So I have some expectations here. I'm saying, hey, with this mock data, I want the API that's being mocked to send back data that is similar in form to what would be expected in the production environment. So when I call the function to fetch data, I'm able to test that my decoding works, the data that I'm getting is valid, and yeah, as you can see here, I'm basically saying when I call fetch user profile from this service object, I'm able to see that the service object correctly returns the user data, and it has the ID, the name, the email, profile picture, etc. And if it didn't, then I will fail this test. And expectations are a neat way of testing completion handlers. We can take a look at that at another time, but the takeaway here is that it's possible to test behavior and complex networking requests without using your live production environment and costing your company money. We can test for free, which is awesome. Okay, and the same goes for the opposite. If we want to test for errors and how our systems will react for errors, we can also do that. Same structure, given, when, then. We stub the mock object with an error, and we can set that error to so many different things, so many different status codes. And when we make that call to the service object, if it fails, we're expecting a failure here in this case. So we would call this a pass test. But if we see the system under test, the service object fails with the wrong error, we would fail this test. This is really important. Actually, I'm going to double down on this. So with the network, the service object that controls the network, the networking calls, we have established error messages that get passed to any parent objects, such as like views or view models, and those view models will react accordingly. So we need to make sure that those error messages that are being passed on to the parent objects are correct. So you have the flexibility to test for those specific error messages as well. And yeah, I just wanted to double down on that because I think that was something too that was that was kind of eye-opening with the potential for testing. All right, I'm going to keep it moving. We kind of covered this earlier, but you can also test with modern Swift async await. Similar setup. We have the overridden setup function here. Set up your mock client, set up your system under test, and we want to set these to nil after each test. So these two functions, setup and teardown, they're called after each test. Setup is called before each test case is run, and teardown is called after each test case is run. And the reason why you want to ensure that you're setting these to nil in teardown is that you don't want to contaminate the test conditions for following tests or like subsequent tests. So if I make a test where, yeah, let's look at this as an example. We have like a successful user profile fetch. I don't want the mock data or the conditions in the successful case messing up the conditions for the networking errors and vice versa. So that's important to note as well. And yeah, once again, if this is a lot of information I'm dumping on you guys, but if this is confusing or you have any questions, just drop them below or send me an email. All right, I'm going to keep it moving. View models. What I love about testing view models is that it is like a direct relation to the view. So the importance of unit testing is so strong here because that you're just closer to the user and how they're using the app. The behavior is like one of the more critical parts of the view model. So if you're able to test out like that core functionality and the core behavior, that's super, super important. In this example here, I have like a chat-based app, like a chatbot app, and I'm still using the same principles that we discussed earlier about mocking data and mocking the network service, mocking out the storage service, and populating that into the view model. Still doing my same teardown methods. And one test that we're looking at here is that when someone types into the toolbar, we'll be referencing the input text, and I'm basically like mocking out that behavior. So I'm saying, hey, someone's typing, they typed in hello Claude, and we're going to make a call to send that message, because that's the function that gets called when the view layer send button is tapped. So we're just mocking behavior through code, which is awesome. So we're saying, hey, given when then, given the user's typing, when we send a message with this view model, then assert that, a message is built and the input text is now empty because we want to clear out that input bar or that input text once the message has been sent. Okay. So at this point here, you've kind of seen testing from domain model to service layer to some of the view layer with the view models. And for Swift UI, like I think that would be adequate. Like I really wouldn't feel pressure to write unit tests for Swift UI, given that the previews are so powerful, right? Like you can establish what your screen will look like with preview, and preview you can set up the same mock data to show the different states of your screen. But with UI view controllers, if your company or your project uses UIKit, you actually have some power to using unit test. And once again, I don't think this is like the rule to always have unit test on your UI view controls. I think some might see that as extreme. I think it's more of like if it's a critical service or a critical surface and you're a little unsure of like what the user behavior might be, or you just want that confidence, like saying, hey, this is my team's #1 feature, this cannot break by any means necessary. Having the unit test suite set up will be good for your confidence and good for your sanity. So what we're going to do is take a look at this simple UI kit. view, this UI view controller. This was built with programmatic layout, just a few titles or labels, and a couple buttons. So what we can do is also bring that same structure to our test case to test out the behavior of the UI view controller. Once again, like, some might see this as extreme. I just see that it's like another option for us to add more code coverage to our code base, and it can be valuable. I don't see anything wrong with this, but let's keep going. So let's say we want to test like the initial state of the screen. The given would be, hey, the view controller has just been initialized. We handle that in setup. The view loaded, also handled in setup. Then we're going to test the behavior of certain screens, or of the UI screen or UI view. And we're going to get the counter value. I have like a helper method down in the test case. And I want it to be 0. I want to make sure that the message is visible or not visible, because it should be hidden initially. So it is an assertion for a false assertion. And I also want to test the text in the label, so I can do that as well. Once I get the counter label, I just check the text, and I am asserting that it says counter 0, which it does. Okay, so now we want to test some behavior, and the given would just be, hey, let's grab the increment button. And once I get the increment button, I want to set the condition that someone just tapped it. And you can do that through the send actions function. And you can say, I want it to touch up inside. So this is basically saying, given the screen loaded, grab the increment button, now tap it. So when someone taps this button, then the view controller should change its counter value to 1. And that's what we did here. And we touched the button 2 more times with these functions, and we're testing that it's set to 3. And yeah, this is like a valid test suite for UI view controller. All right, don't worry, I'm almost done here. And yeah, once again, if you have any questions, I know this is a lot, feel free to ask in the comments. Like, if you want to see more unit tests for view controllers, send me a comment or send me an email, and I'll do my best to write up some code and share it on here again. Yeah, one thing that's really powerful to see is code coverage. Some people take it to the next level, and they will establish rules on their pull request. You'll typically see as like a large company where there's so many people. I like to call them cooks. There's so many cooks in the kitchen that you want to ensure that quality, like a quality bar, is set with every push to the code base or to the GitHub. So some companies have rules on their PRs where you can't push code to the main branch if you don't have code coverage at a certain percentage. And I think my last company, I think it was around like 80%, which I think is fair. So any new file, they want to see some code coverage, just because at that scale, and with the amount of users in hundreds of thousands, potentially millions, it's kind of risky to push new code especially, without any test. So yeah, I walked through how you can see your code base's current code coverage metrics. And it'll look something like this. It'll look at the lines covered and the percentage. This is for the chat bot app that I built. And yeah, taking a step back, I think we shared a lot of best practices here. What I like to do is keep the test really small and focused, just one thing at a time. Use very descriptive test names. So as you saw throughout my examples, like, they were very, very descriptive. Follow the pattern of given, when, then, or the arrange, act, assert. Yeah, focus on the behavior, make the test independent, And once again, these are all like just really good clean code principles that I think the tests are bringing to light, and that's why I think that unit tests are valuable. Yeah, test all the edge cases if possible, but don't strive for like 100% code coverage. I think you can really get bogged down in that stuff, and um, just make sure to see the forest for the trees. um, and focus on the big picture. Run your test often, ideally before each commit if you're on a large team especially. You can set up CI/CD pipelines. Those are just like quality assurance tools. Third-party tools, we only focused on unit testing here, but I like to use this library called snapshot testing for UI snapshot testing. Um, I think for UI view controllers, it's really handy. I think snapshot tests for me are less valuable with Swift UI, given that you can just see it in the previews, but I still think they're valuable to have. Okay, we covered some common challenges like networking calls. It really forces the engineer to consider dependency injection and using mocks instead of making real network calls, especially to save money. Storage layers, if possible, you can swap out um, the storage layers with like just like a more simple store for test suite. So like if your storage layer uses like, I don't know, SQLite or core data, it's possible that you can swap that out at runtime through dependency injection and just use like a simple in-memory store. And testing complex UI, like if it's super complex and the setup is just like a pain, just consider using snapshot testing with test-backed view models and and service layers. And yeah, I think this is probably another critical part of the video. It's just getting the team on board. I'd say, start small and show the value of test, which is the confidence that it brings to the team and the development cycle. And also, like, you can also chart how much quicker you're becoming because you're not manually testing out certain flows because you have it all covered in unit test. Um, I think it can be a touchy subject, especially if you're like a junior engineer trying to convince like senior level folks to get on board. But I think if you show them and lead by example, it'll be hard for them. I find it hard for them to deny the value in setting up test. Yeah, we talked about CI. It's just like a quality assurance pipeline to automatically run your tests. If you work at a large company, definitely consider this. And in conclusion, I think the setup may be a little tedious, but I think at the end of the day, like they're put in place to reduce the number of bugs in your code base and to capture any issues before your user does, which ultimately saves you time and the company money. And yeah, I just kind of like sped run through all of this, but I hope you found this all very useful. Once again, feel free to share any thoughts or comments in below the video or send me an email asking for more code examples or videos. And yeah, definitely check out this document. I'm going to link it below and you can just, grab that when you're done watching this. Thank you for your time. Have a great day. Bye.